as is. So using the table, so negative 2.50, the area of negative 2.50 is 0.0062. So therefore, the probability that the sample mean is less than 2.2 is the same as the probability that the z-value is less than negative 2.5 is 0.0062. Okay, next. Number 2. A.C. Nielsen reported that the children between the ages of 2 and 5 watch an average of 25 hours of television per week. Assume that the variable is normally distributed and the standard deviation is 3 hours. If 20 children between the ages of 2 and 5 are randomly selected, find the probability that the mean of the number of hours they watch television will be greater than 26.3 hours. Okay? So 26.3 hours. Remember that the mean of the sample mean is equal to the population mean. So therefore, your population mean is equal to 25. And then your standard deviation is 3. Then your sample size is 20. So what is the unknown in the problem? So the unknown in the problem is to find the probability that the mean of the number of hours is greater than 26.3. Okay, so find the probability that the mean of the number of hours is greater than 26.3. So first, solve for z value. So mean minus the population mean over the standard deviation of the population divided by the square root of n. So that will be 26.3 minus 25 divided by 3 divided by square root of 20. So your z value is equal to 1.94. Okay, so 1.94. So the probability that the sample mean greater than 26.3 is the same as the probability that the z value is greater than 1.94. So using the normal curve, so you need to draw a normal curve. 0 is the middle, so 1.94 is located on the right of 0. So assume that this is your 1.94. So this is your 1.94. Greater than 1.94, so going to the right. So therefore, the probability will be 1 minus the area of 1.94. So how do we determine the area of 1.94? So get a table. 1.94. So 1.94. So this one, which is 1 minus 0.9738. So the probability will be 0.0262. Okay, so that's it. Next, number 3. The average number of pounds of meat that a person consumes per year is 218.4 pounds. Assume that the standard deviation is 25 pounds and then the distribution is approximately normal. So it's normally distributed. Okay, letter A. Find the probability that the person selected at random consumes less than 224 pounds per year.
Before we answer letter A, what are the given? So these are the given. So first is the population mean, which is 218.4, and then the standard deviation, which is 25 pounds. So in letter A is find the probability. So find the probability that a selected person. So how do we represent selected persons? It's unknown. So you just represent it as X. So selected person less than 224 pounds. Okay, so we need to find the probability that selected person is less than 224 pounds. So since the given is not a sample mean, this one is not a sample mean. So how do we solve for z value? To solve for the z value, you need to apply the first formula for z value, which is x minus the mean divided by the standard deviation. If the given is not a sample mean, okay? So z is equal to 224 minus 218.4 over 25. So the z value is, so you get your calculator. So 224 minus 218.4 divided by the standard deviation, which is 25. So your z value is 0.22, rounded off. Okay, so 0.22. So therefore, the probability that the selected person, which can be represented as X alone, less than 224 is the same as the probability that the z value is less than 0.22. Okay, so you draw a normal curve, 0 in the middle. So where is 0.22 located? Here. So this is 0.22. Okay, 0.22 is on the right side of 0. So this is your 0.22. Assuming that this is your 0.22. So it should be less than 0.22. So less than 0.22. So less than 0.22. So what is the area? Less than 0.22. So since the area is going to the left, so it's as is. So 0.22. 0.22 using the table. So 0.22. 0.22. So that will be 0.58. 0.5871. That's it. Okay. Next, letter B. So letter B, if the sample of 40, so there's a given sample. If the sample of 40 individuals is selected, find the probability that the mean. So find the probability that the mean of a sample will be less than 224. So can you see now the difference? This time, the given is a sample mean. In the previous example, it's only X because you're pertaining to a person, selected person. In letter B, it's not X anymore. It should be sample mean because it's according to the given. Find the probability that the sample mean is less than 224. So since the given is a sample mean, to solve for the z value, apply the second formula, which is sample mean minus the population mean over the standard deviation of the population divided by the square root of n, because you have already the given sample, which is 40. Okay? So what is your sample mean? Your sample mean is 224 minus the population mean, which is 218.4 over the standard deviation, which is 25, divided by the square root of 40. So what will be your z value given the sample mean? So this is your central limit theorem. If the problem answers on the questions about sample mean, we call it central limit theorem. Okay, so get a calculator. So 224 minus 218.4, okay, divided by 25 over the square root of 40. So the answer is 1.42. So that is your z value, 1.42. Okay, so the probability that the sample mean is less than 224 is the same as the probability that the z value is less than 1.42. Okay, so using the normal curve, as always, you need to draw a normal curve. So 0 is the middle. So where is 1.42? So 1.42 is located on the right side of 0. So assuming that this is your 1.42, this one. Okay. So 1.42. It says in the problem, less than. So less than 1.42. So going to the left. So going to the left. Okay, so if the given is going to the left, so the area is as is. You don't need to subtract it by 1 because it's going to the left. Okay, you can only subtract it by 1 if it is going to the right. So in this particular figure, it's going to the left, so as is. So using the table, so 1.42, 1.42, so 1.42. So this one. So 1.42, that will be 0.922. So the answer is 0.922. That's it. Okay. So again, when we say central limit theorem, if the questions of the problem deals with sample means, therefore that problem focusing on central limit theorem. Okay?
So formula use, number 1, z is equal to the x minus the population mean over the standard deviation used to gain information about individual data value when the variable is normally distributed. The second formula, which is for central limit theorem, used to gain information when applying